10.1 vectors. Well, you've probably talked about vectors if you've been in physics, but just to give you a kind of quick little review, right now when we deal with stuff, we've dealt with temperature, mass, time, length, all those things were things that can be measured or we can express using what are called scalar quantities, which is mainly with real numbers. Well, when you deal with force and velocity and acceleration, well, these no longer are just quantities that have a number. They're quantities that also have a direction. So they have magnitude and direction, and we have to use both of those when we're describing them. So that's where we bring in vectors. Vectors are basically, like it says here, a directed line segment that has an initial point P and then goes towards the terminal point Q. So we start at one spot, which is our initial point, and then we go towards, whoops, I'm not on a pen. Helps if I point with the pen. Start at an initial point and go towards the end point, and that's the terminal point. The way you calculate that is basically by doing the distance formula, which is find the difference between the x's squared plus the difference between the y's squared. Or you can also consider that basically we're just doing Pythagorean theorem. We're going to find this distance, which is the difference between the x's, that's our x squared. We're going to find the distance between the y's, the y squared, and the square root of that will give us the length of the magnitude, or the length of the vector there. Now, one of the traits on vectors that we're going to talk about is how to add them up. And visually you add them up by, you start at the first initial point, you go in the direction of the first vector, then if you're adding to it, you put that next vector at the end and add that to it. Like if I were adding a plus b, we start with a, what a does. Well, b shows going to the left, so then we go to the left. Well, our answer, our resultant vector, is that outcome. That's the one we're looking for. I think they'll also call that the position vector, and we'll talk about that also. And if we were subtracting vectors, you would add the negative, which means the opposite direction. Like basically 180 degrees the other way. So, looking at this other example, if we took a plus b, and then c goes up and to the left, that amount, d goes straight down, our resultant vector, is this one in black, would be from where you start to where you end, right there. So, let's practice those. Like if we wanted to take a plus b, well, a went like this, and b went down a little, so our resultant vector would be from where we started, which let me switch to a different color, where we started to where we ended up. So there was the vector AB, our resultant vector. So for E went, I'm going to take E and C. I notice I'm going to go backwards, so let's see. E goes up about someone in there. C goes back a little bit. Then it says plus D, which is down quite a bit. And then plus B, which is down straight more. So our outcome on that one, the resultant vector that we're looking at, or the position vector, is going to go from here to here. So that's the one we're looking for. And let's look at C. C is a true-false version of the same thing. So if we start at E, and go down to D, and then add A to it, do we end up, if we end up back where we started, well, it's true. That would be, I think, assuming these are accurate, that amount, and if that's the exact same amount as that, then yes, it's true, and that's what we want. The main reason we put this one here is because you're going to have some true-false, and 0 is when you end up back where you started, where it's like a displacement of 0. So, let's see. To identify vectors, like this one on number 2 says, give the initial point, which is point P. So, and that starts, on this one starts at 0, 0, so there's my P. And then Q is the point 4, 3, so over 4 and up 3, there's where Q is. Well, the vector we're talking about goes from P to Q, so we're looking for that length right there, that vector right there. And to find its length, if you have a graph, it's really easy to look in terms of Pythagorean theorem. So we went over 1, 2, 3, 4, and we went up 1, 2, 3. So 4 squared plus 3 squared, so that would be 4 squared plus 3 squared, or if hopefully you've learned by now, special right triangles, 3, 4, this will be 5. But to calculate that, it's 16 plus 9 inside the square root, which is the square root of 25, which is 5. So that is the magnitude of PQ, is what this is asking for. And we found its length. The length of a vector is called its magnitude. The magnitude of PQ was 5. So on the next one, we're going to do the same thing. So the first initial point is 0, 4. So over 0 at 4, there's our P. Then I'm going to go to -3, -1, which would be right, oops, that's not right here. And that's our q. And so we're trying to find that length of that vector, which is the magnitude. And if we look at it in terms of Pythagorean theorem, this is 3. This is 1, 2, 3, 4, 5. So it's going to be the square root of 3 squared plus 5 squared, or 5 squared plus 3 squared. I don't care which one you do first. Which is 9 plus 25, which is the square root of 34, and 34 is 2 times 17. There are no prime factors, or no perfect squares, so that is the magnitude of PQ. Okay, let me double check before I move on. Make sure I didn't make a mistake. Okay, I'm doing it right. Now, C, we're doing the same thing, but we don't have a graph this time. So you could sketch a graph if you needed to, or we can do it by to find the magnitude of PQ. When you don't have a graph, you can use what's called the distance formula. The distance formula is just a formula way of doing Pythagorean theorem. We're going to take the two x's and subtract them. It does not matter which one you do first, because when you square it, you're going to get a positive value. So if it makes you feel better, you could have said 5 minus 2. And just like on Pythagorean theorem where we took one side squared plus, we're now going to do the other side squared, and to find the length of another side, you subtract the two y values. So 5 minus 1 or 1 minus 5 does not matter, because the squaring will make it positive. So this will be -3 squared, which is 9, or positive 3 squared if you went the other way. This one is 4. 4 squared is 16. And 9 plus 16 is 25. So this one comes out to be 5. It's the same length magnitude as the one we did up above. And on D, let's do that one more time. So Pythagorean theorem, so PQ, the magnitude of PQ is going to be square root of, subtract the x's and square it, so -5 minus -4, plus subtract the y's. I like the positive one first, 4 minus -2. Like I said, if we were talking direction, it would, and if this wasn't squared, it would matter which one goes first. But since it's squared, it doesn't matter which goes first. So that makes that 6 squared. That's -5 minus -4 is -5 plus 4 is -1 squared. All inside the square root, which is 1 plus 36, which is square root of 37, which can't be simplified. So there is our magnitude of PQ on letter D, 2D, sorry. Okay, some other traits we need to know is when you're talking about vectors, you can talk about them in terms of the horizontal component and the vertical component. Well, they'll refer to the horizontal component as AI and the vertical component as BJ. So A and B are the values of how much you moved. So like on this one, in this picture, A would be 1, 2, 3, 4. So this would be 4i. And then B would be 1, 2, 3, 4, 5, 6. Well, if it were on a point, if it stopped at that whole number there, it'd be 4i plus 6j. And that would be the position vector that we'd come up with. So vectors can be broken up into their horizontal and vertical components. We split it into the horizontal distance and the vertical distance, where A is the horizontal, B is the vertical. You'll also see it written in different notation, so we wanted to get used to that. That is where you're looking at just the two numbers, V1 and V2, the vector 1 and vector 2. It's like a horizontal vector and a vertical, the horizontal vector and the vertical vector. And again, those can be found by doing distance formula or Pythagorean theorem. And the resultant vector is also called the position vector. I mentioned that on the first problem. And we write it in AI plus BJ form. Basically, A is the change in X and B is the change in Y. So, looking at number 3, we want to calculate the magnitude of V, which is basically going to take the A and the B squared and square root. So this one, the magnitude of V is going to be square root of 3 squared plus 6 squared, which in this case would be square root of 9 plus 36, which is the square root of 45. But 45 is 9 times 5, and we know the square root of 45, so this would be 3 square root of 5. On 3b, this one is matching this form where we're just going to use, it's just those numbers. It's still the same thing. We're just still doing Pythagorean theorem, basically, or distance formula, which is Pythagorean theorem, just in the formula form. So we're going to take 4 squared plus -5 squared, which would be 16 plus 25, which is the square root of 41, and 41 is prime, so that is our answer, and we are done with that one. Okay, last one says the vector v has initial position p and a terminal point q. Write v in the form of ai plus bj. That is basically find its position vector is all it's asking. So, just like on all the others, we need to find the horizontal part, the change in x. So I need to find change in x, so I can put that as a. So a equals change in x, b equals change in y, and then we put that together and make that ai, just like we have right there, ai plus bj is what we're going to try to write. That's our goal. So change in x, let's find out. In this one, direction does matter. So we have to take, if we think of where this graph is, we're at -2, 4, which is up here, and 5, -3 is down here. So our resultant vector is going to be going down and to the right. So that means we have to have a positive x. So to find this change, you have to take the second minus the first. So our change in x is going to be 5 minus -2. Whoops, I'm thinking ahead. 5 minus -2, which is 5 plus 2, which is 7. So a is 7. The change in y, take the second minus the first, is -3 minus 4, which is -7, which makes sense since it went down. B should be negative, so B was -7. So our final answer to this one is we take the A, put it with an I, plus the B, which happens to be a minus, so you could say plus -7, or we can just, instead of saying plus a negative, we can say minus 7. I should have made them where they weren't the same number. Not B, 7J. Say 7J, and that is our AI plus BJ form. So that is everything you need. Like we said, we're starting vectors, and we wanted to get you we know you've seen it briefly in physics, but if you've had physics and we weren't sure of the depth, so we wanted to make sure that you were well prepared. So we're not going too detailed yet. We're going to start here and we'll move forward from there. So that's everything you need to get assignment 10.1 done. Good luck to you.